we finally come to the last foundation of statistics and probability. Quantify probability. If I say my favorite team more likely to win the next game, you probably feel that it is a very vague statement. I can do it better. My favorite team has a 80% chance to win the next game. How to come to that percentage? Well, you may think it must be very complex and even unachievable. Actually, it could be fairly simple. There are only 3 principles when quantifying the probability. Permutation and the combination method. Let us see an example. What is the probability of a rolling dice stops showing 6? There are 6 positions the dice may end up. 1, 2, 3, 4, 5, 6. 6 is one of them. So that the chance of get 6 is 1 to 6. The key to quantifying probability using the permutation and the combination method is to find all possible outcomes. We can use permutation and combination to deal with a single random event, but what if there are multiple random events? Sum method. When calculating the chance of A happens or B happens, we can sum each probability together. Given event A and event B won't happen at the same time. Use the dice example. What is the probability of getting 6 or 5? Since each event has a 1/6 chance of happening, the chance of getting 6 or 5 is 1/6 plus 1/6. Multiply method. When calculating the probability of independent events happen at the same time, we can multiply each probability together. For example, what is the chance of while stacking in traffic and find out the car is running out of gas? For me, it's like half times. So it happens. It's worth to mention here the difference between probability and odds. The odds are defined as the chance that event will occur divided by the chance that the event will not occur, while the probability is that an event will occur is the function of times you expect to see that event in many trials and always range between 0 and 1. It is probably easier to understand by an example. Say the odds of my favorite team win the next game is they win to lose. The probability of my favorite team wins the next game is they win plus lose. In the real world, the problem is generally more complex and won't be as simple as the examples. But don't worry, there's another 3 methods will bring your probability quantifying skill to the next level. First, definition. As the name, sometimes we just assign a probability to an event. Think of toss a coin or dice. You just assign the chance of showing one side as half or 1/6. However, there is no perfect coin or dice that all sides are exactly the same. So this method simplifies the world, gives us a chance to build the model and study it. Keynes said in his book, if there is no known reason for predicating of or subject one rather than another of several alternatives, then relatively to such knowledge, the decision of these alternatives have an equal probability. This classical definition is also known as the principle of equal probability. Second, frequency. The principle of equal probability is easy to apply, but soon we find out that a lot of events don't have equal probability, such as the defective percentage and gene mutation. Although we don't know the percentage, we do know that assume the chance is 50-50 makes no sense. To solve it, frequency comes to this stage. It defines an event's probability as the limit of its relative frequency in many trials. For example, in order to find out someone's shooting average, you can let him to shoot many times. As the sample growing bigger, the shooting average will get more and more closer to the true percentage. This method is widely applied in many fields. I will discuss it in more detail in next few episodes. Third, iteration. While the frequency method can be used to find out all probabilities, I think you will agree that people's shooting average will change, given he has a lot of practice. His shooting average probably gets improved, and sometimes we simply can't repeat the event many times to find out the frequency, like forecasting tomorrow's weather. But don't worry, we still have another tool to address this kind of problem. That is iteration. We have to make a guess, and then as more information emerges, update the predict accordingly. The most famous iteration is Bayes' theory. I'm always here at your service. See you in the next one.